Hi, my name is Dan Baronet for Dyalog, and we're going to be talking today about object-oriented programming. And object orientation was introduced in Dyalog EPL in 2006, along with some other features. And today we're going to be seeing why you should know about object-oriented programming and how to use it in APL. Okay, why would you want to do this? Well, object orientation is a valuable tool of thought. You should be able to share your tools more easily with other people. It should help you to manage complexity in all phases of projects. And it should allow you to use .NET more easily. Object orientation is just a tool for programmers. The users are not going to see anything special. They're not going to see any difference. You're the one who's going to see the difference while you're building your application. It's really a way to simplify your life in many ways. Now, the evolution of data over the years has been going more or less like this. Originally, there were just elementary data elements, just like integers and characters and type of stuff like this. And then eventually people came up with structures. For example, you could combine integers and characters, make them into dates, combine those with some other things. And eventually this became namespaces where you associate names with elements. For example, you can have a name associated with a particular element. And then eventually from those were built classes where you can initialize the objects and clean them up and do all kinds of things. And in the future, I don't know what they're going to come up with, but it's probably going to be based on that. So previously what you had your code was separated from the data. You had global variables and then you had your code. And it was, it worked, but it was a bit messy. Sometimes you had, data all over the place, so it wasn't clean. Just like you have local variables in functions, you may want to localize some names with the objects themselves, and this is a little bit what happened with objects. In APL, it was exactly the same thing. We had global variables, data all around the workspace, which made things a little bit more complicated than they should be sometimes. So with the OO system, you have data is much more tightly coupled with the code. So you keep your data with the code. The data that's relevant to the code, you keep it with it. And you can separate things in modules, functions, and just like you would do normally, but within a closed system. In APL, it's exactly the same thing. You're going to have your code is going to be associated with your data. It's going to be encapsulated into one object that will confine the events. So what I'm going to do now, I'm just going to go over some definitions that you will find anywhere in any book on the net, anywhere. These are just the definitions that you will find. There's more than that. You're going to find less than that too, but these are the terms that you will see in general. So you've got classes, instances, members, message passing, inheritance, encapsulation, and polymorphism. These are the terms you will hear in the OO world there. So let's start with classes. A class is like a blueprint. It describes what the object is going to be like. It comprises data and code. So you're going to what you call members. So these in the slides here, what you see in green is something that you will see in APL later. What you will see in Italics, for example, members, is not something you will see in APL, but these are the terms that you will hear all the time. So, for example, here we have a house blueprint. So it's not a house, it's just a blueprint. We're going to have the same concept in object orientation. One of the things that a class can do is it can implement what is called an interface. The interface describes what it should do, and the class describes how it should be done. So if a class implements an interface, it does it entirely. There's no partial implementation. Remember, these are just terms I'm telling you. This is what you're going to hear in the literature. So for example, here's one where you have, if somebody wants to make use of the electrical system, you devise an interface. The interface is the plug. So this is something now, if you went to a different country, your plug may not work, but I mean the system is the same. They have an electrical system. If you want to make use of your appliance, you have to use the interface. Trying to play with the wires is not recommended. Okay, here's an example. Here's an interface where you have, the interface says that to maneuver a device, it has to be a machine, it has to be done this way. You have to have a method that can steer the machine, another one that can accelerate the machine, another one that can slow down the machine. It doesn't tell you how you do it. All it tells you is that if you want to maneuver a machine, you have to be able to do these things. It doesn't say anything about the machine itself. That's all it says. So if you go, for example, if you want to have a car that will implement maneuvering, the car, for example, in this case, will implement the method steering wheel, which implements the maneuvering steer. So if you remember in the other one, we had one called steer in the maneuvering interface. We had one called accelerate in the maneuvering interface. We had one called slow down in the maneuvering interface. Well, if this car is going to implement maneuvering, it will have a method, in this case called steering wheel, that implements the maneuvering steer. It has another one called gas pedal that implements accelerate. It has another one called brake pedal that implements slow down. So this is for that machine called car. Here's another one, another machine, a plane. And this one implements maneuvering another way. It uses yoke. The other one to accelerate uses handle. And the other one to slow down uses flaps. Another machine would implement it another way. It doesn't matter. These are just the terms. It says that I want to implement maneuvering. I do it using these methods there. You could use the same names too. There's no reason why you can't, but you don't have to. And that's the beauty of it, because you can actually use whatever name you want, and it will be associated with the proper interface method. Instances, second term. These are the objects that you create from your blueprint. For example, the house blueprint we had before is not a house, it's just a blueprint, but you could make a house out of it, and you can customize it. You could have different houses made out of it. One would be blue, the other one would be green, the other one would be red, but it would be made all out of the same blueprint. So when you create it, you have one of the methods you define as being the constructor. That one will do something. It's like the quad LX in a workspace, for example. When the workspace is loaded and you get something is being done. Well, this is the same thing here. When you create an instance from a class, then one of the methods can be called to do something about your object and initialize it, do something about it. And when you destroy the object, it's the same thing. When you get rid of it, you can actually decide clean up. If you destroy your house, you get somebody to clean up the terrain after or something. Oh, here's my example with a house. Once you've created your house, you've decided you wanted a new house and it had to be blue. So you picked up the blueprint, created the house, and right upon creation, you painted it blue. So, members. This is the code and the data of the class. The code is divided into methods, which we do call functions. And the data is divided into fields, which we call variables. There's also something that we are not used to. It's called properties, which are basically fields that you implement with a couple of functions. And we'll go over that in a second. The members, the code and the data, they can reside in the class if they are shared, or in the instance if they are to be proper to the instance itself. So you could have something that is common to all the instances, to all the objects, and instead of keep it, you have to have a place where to keep it, so you keep it in the blueprint itself, in the class. So for example, there's a .NET class which is called datetime. And datetime allows you to create an object that manipulates date and time. But there's one of the members, one of the methods called now, that doesn't require an instance. It is going to give you today's date and time. It doesn't have to be in any object. You can just ask the class, tell me what date and time it is now. So you could go directly and ask datetime.now, and it will tell you right away what the date and time is. Pretty much what the time is now, right? No, it's the wrong date. Okay, are there the same shared versus instance? Here we have three members in the class, S1, S2, and S3, and we have objects which have their own instance members, I1, I2, I3, I4. So S1, S2, and S3 are going to be kept in the class, whereas each copy of each instance will have its own copy of I1, I2, I3, and I4. So the methods, they can be shared if they reside in the class, or they can be instance if they reside in the instance. There's also the concept of what they call abstract methods, which has no code, only the calling syntax. And we saw that before in the interface. It only describes what the syntax of the method is going to be. We don't have that in APL, not at the moment anyway. But you will encounter the term eventually. Constructors and destructors are also methods. Fields, same thing. They can reside in the class or in the instance, and they can be read-only. Properties, same thing. They can also reside in a class or in the instance. And the way it works is that when you actually specify a value to the property, just like you would do with a variable, what happens is that a function called set with the value is called. Message passing is another term you will encounter. In our case, what it means is just a call to a function. I'm not going to talk about this anymore, but I thought you will encounter the term. So, inheritance. This is one of the cornerstones of OO. It's trying to avoid rewriting code. We have the same thing in APL anyway, or any language. Usually you have a function that is working. What you will do is that you will modify that function into another one, or call that one if you want to. Everybody does that. It's not just APL, it's every language. So it's the same thing here. You build a class, the class is doing something useful, and you don't want to rewrite a new class entirely. You don't want to copy it. So what you do is that you use it, and then you build on it. You will add things or replace others or things like that. It's the same thing. So what you do is that you inherit from a class, you call it the base class, and you will. And of course, this can be done several times. So class A can inherit from class B, which has been inheriting from class C, and so on and so on. This can go at several levels. So that helps you reuse the code. We say that a class is based on another one, if it's and it is itself derived. Okay, here we have several classes, one called animal, from which is based a couple of classes called dog and fish. And from the dog, we created a couple more classes, one called Great Dane and the one called Collie. And eventually from the Collie, we created two objects, one called Fido, which is a Collie, and Rex, which is also a Collie. So here all the blue boxes are classes, the green one is an instance. Fido is an instance of a Collie, and it also has the characteristic of a dog and an animal. Here's another thing that you will hear called multiple inheritance. So you can have a class based on two or more other classes. There's many ways to do this, and not all languages do it in a consistent manner. And there's a lot of disagreement in that field. So Dyalog APL has not implemented that. We do it some other way using interfaces. Here you have, you can simulate multiple inheritance, just like I said with the interfaces. Here we have a class that implements two interfaces. The penguin can swim. It doesn't fly. It has 1 egg per year, and it croaks. Well, we all do, but eventually. So you can see that another way to achieve multiple inheritance is by using multiple implementations. When an instance is created from a class based on another one, it inherits all of its members automatically. Some of its members can be redefined, but the subroutines themselves must be set specifically to be overridden. And I will explain that in a moment. It's let's see here. We have inheritance. A derived class inherits all the base members. And you have C1 here, which has two members, A and B. And then you have C2, which is based on C1, which has C and D. But C2 should inherit everything from C1, so it will end up with having A, B, C. Something is, hang on. Oh, sorry, I'm looking at the wrong screen here. That's why it wasn't working. Okay, so you get C2 ends up with the members of C1, which are A and B, and C and D, which have been added to the class. Like I said before, initialization is performed by a constructor, and if a class is derived, the base class constructor will also be called if there is one. So in other words, if I have a class that is based on another one, when you construct it, the base class will do its own construction, and then the derived class will do its construction too. Another thing that is sometimes you will see that some classes are sealed to prevent other classes from inheriting them. So that means, for example, you lock it. You say, I don't want anybody to derive from me. My class is the end product. We don't have that in APL, but you will encounter the term. Here's the override concept I was talking to you about. We have two classes, A and B, and M1 is a method that calls M2. And as you can see on the left, class A, if you actually call its method, it will say, M1 will call M2, will say I am A. That's fine. Class B does the exact same thing. So it calls, it says I am B. If I decided that instead class B should not have the same code, but it should reuse class A's code, I say, okay, class B is based on A, so it's got M1 and M2, but what I would like to do is redefine M2. M2 is not a method that you can call. It's one of the subroutines of F1. So if you do it this way here, what will happen is that when you call M1, it will call M2, and you will end up with I am A anyway, because you're not overriding the function. Now this guy, when he wrote his class, maybe he didn't want it to be overridden. So that's the reason why you can't do it. Even if you say, I would like to override it, so B says, my method 2, I would like to override it. Well, it's still not going to happen because this guy here didn't say you can do it. So if you run the code, even though you've tried to override it, you're still going to get I am A here. So there has to be an agreement. First of all, A must say I am overridable, and B must say I want to override it. And in this case here, when M1 is called, it calls M2, but since it's overridable, and that this one can override it, then what happens is that this code is called, and it says I am B. Now this can be useful, for example, if you have, I don't know, you have a class, and you don't know which language is going to be used. So down below, you say, I'm going to use a generic language. Let's say, I don't know, pick by default, English. And then when somebody in Russia decides to use a class, says, well, you know what, I'm going to be overriding this method here with the Russian version, and somebody else with the Danish version, somebody else with the, well. Okay, encapsulation. It's like localizing names in a function. You localize, you encapsulate everything so that it can't be seen from the outside. Nobody knows how it works underneath. The way you've built it is, you don't want people to come in and say, oh, he's using this thing, therefore I know he's doing this, I'm going to take advantage of it. Because you may want to change your mind later and re-implement it another way. So you're not telling people how it's done, you hide how it's working. So for example, let's take a car. We don't know how it's done below. This is what it really looks inside. But you don't want people to start mucking around with the wires and everything. So what you do, you present them with that one interface, which is the outside. All they can do is touch the steering wheel. They can't do anything with the rest of the car. Okay. If you want to allow access to a member of a class, you must use a special syntax to say that it's available. It is public. So this is the term that you use. You say that it's public, and this is the term we're going to be using in APL also. By default, private is the norm, which means that if you don't tell that it's public, APL will assume that you want it private, and that's the way it's going to be. So nothing will be seen from the outside. So if you say something is private in this class here, I think the dark blue is the public area, and the pale blue is the private area. So, for example, M here can only be seen in that area here. So if you're here, you can't see it. If you're there, you can't see it. It's private. You cannot see it. If you say it's protected, and protected is not something we have in APL, but I'm letting you know anyway, is that you're saying, I have an object here. Anything that is based on that class will be able to see it, but anybody outside of the class or the derived class will not be able to see it. That's another level. And finally, public means that anybody can see it. So if you're inside or outside of the class, you can see it, and whether it's shared or in an instance. And finally, there's another concept called a friend. And we don't have that either, but it exists. It allows another class to be able to see inside your class. Probably an example would be an elevator, where you have, when you get into the elevator, you can only see the buttons and everything. So you cannot see the wiring, just like inside the car. You can't see how it's done inside. But the guy that has to repair the elevator must be able to go inside and see it. So he's a friend of the elevator. So the repairman object is a friend of the elevator object, meaning that he can go inside and change some of the methods and the wiring and everything. He's not allowed to do everything, but some of the things he's a friend you can see. Last term, polyformism. This is behavior that allows a single definition to be used with different types of data. This is more something you see in other languages, for example, in BASIC or C or something like that. It's a way to call the same code, the various sections of code using the same name. In a way, we can do this in APL by looking at it. We can branch into the function and say, well, if it's type character, I'm going to do this. If it's type integer, I'm going to do something else. It's a way to go around it. But other languages will tell the difference by looking at the signature and then you're going to have function X. If it's an integer, you do this. You're going to have another function X, which if it's a character, you're going to do something else. It's another way to do it. Oh, here's two functions. One is called integer, and then you do some. This is an example taken from, I think it's basic, where if you have a number, you print the number, and if you have a string, then you print something else. In fact, in APL, we already do it. We have, for example, the function plus is already overloaded. If I say 2 plus 2, it prints 4, but if I say 2.5 plus 2, it realizes that one of the arguments is double instead of being an integer, and then says, oh, that's okay, I know what to do. So, and then it will just do the addition anyway. So, and this function here in basic prints 2 plus 2, and if you say plus with a string, it actually catenates them instead of adding them. So it's a different behavior depending on the type. There are more concepts. There's many of them actually, but these are the most common ones. For example, casting is not an OO concept, but it is often used in the literature anyway. So we've seen there's more or less 7 key concepts. There's classes, which are like blueprints. Instances, which are the objects that are created from the classes. They all contain members, data and code. Their access is restricted, and the relation between classes is based on inheritance and or specific access. Questions? No? Okay. Let me show you the Dyalog APL way. We're going to go over the same definitions again, but I'm going to I'll show you how we do it in APL. First of all, Dyalog follows C# very closely. The behavior should be, in fact, identical. The extensions to the language have been made in following with the colon keyword scheme introduced in the 90s. All the keywords that start with a colon. Some new system functions have been added and some new system commands as a result. So let's go over the 7 definitions again. Not necessarily in the same order. Okay, the first thing we're going to do is how to edit a class. If you want to edit a class, you have to, if it's a brand new one, you use the editor and you use the pi symbol, the circle, Control-Shift-O, and then you follow it by the name that you want to edit. And you can see that APL, well, the editor will come up and already have written for you :class, the name of the class that you wanted, and at the bottom it will put an end class and nothing in between. I've put dots in there, but they won't appear when you start usually. When you hit escape, the class will be defined in the current namespace, wherever your namespace was when you asked to edit. If you look at the quadency of the class, you will see that it's a class 9, just like a namespace. And if you look in the new system command classes, you will see that now my class appears in the workspace. The members of a class are a field, it's a variable for us. A method, it's a function. A property, which looks and feels like a variable but is implemented as a pair of functions. And all of them can be either public or private. A method in our case will be either a function, a defin, an operator, but only traditional functions can be made public. Operators and defins cannot be made public. Properties are like variables when you assign them or read them, but as you will see, deal with their cut with a function before this is done. Okay, here's a class that shows a bunch of new fields and their access. The access will be the same for methods and properties. You can see here you have, this is a field, even though it's assigned as a variable, but it's going to be considered as a private instance variable field. This one here is F1. It has no value, but it has been defined as a field. This one is a private
instance field, which is exactly the same as F1. If you don't specify private or instance, this is the default. It's the same as if you had done it. So F1 and F1B are identical. Here F2 is also a private instance, but it has been given an initial value. Here we have a field which is shared. In other words, this field will appear only in the class, not in the instance. This one is also shared but has a value. This one is public and has a value. This one is public and share and read only and has a value. So these are all ways of declaring fields. Here's a series of methods. The first one is private instance, fn1. It's an electric function. It cannot be seen from the outside. The second one is monadic. It is public, and it is used as a constructor. In other words, when you create this an instance of this class, this function will be called. And this one is a dyadic function, which is not only public, but it is also shared. In other words, it will appear only in the class. There may be more than one constructor, depending on if you want to have more than one argument, and we'll cover that in a second. Here's a property. Actually, there's two of them. The first one is private and instance. It's a property that can only be used inside the class. Nobody will see it from outside. And it's actually read-only because there's no set function. So all you can do is say, give me get-only, and it will return you a number from 1 to 99. That's what it does. Second one is public. It's called age. And every time you're going to say, you're going to ask for age, it's going to call the function get, which is going to return you the contents of this field or variable. If you say age is assigned a value, what will happen is that the function set will be called with a namespace that contains the value and the name of the property. So in this case, we take the value, and this, for example, this function here would decide whether or not it can be done. And it would, in this case, signal if the age is not 18, is under 18. There may be another. The namespace also may contain the value of the indices if you had specified, for example, age index 2, 3 is assigned a value, then it would contain the indices, so you can decide what to do with it. Okay, like we said before, classes are like blueprint and they define how things should be. And the way to create a new object is using the quad new function. This is a new system function that has been introduced with the 00 version. And whatever is in the class will now appear in the instance as a copy, not as a reference. For example, if you had a variable that contained something, then you will have your own copy, not a reference to the variable. Okay, quad new takes one or two arguments. The first one is the class. This is compulsory. You have no choice. You have to tell which class you're going to be creating an instance of. And this is not the name in quotes. It's really the name of the class. So if it's ABC, it's not quote ABC, it's ABC. The second, if it's present, is the argument to your constructor. If you don't have an argument, then either the constructor that has no argument will be called. If there's none, then that will be the end of it. If it's present, if you give it an argument, there must be a constructor that accepts an argument. If APL sees there's something wrong in there, it will complain and give you a length error. Okay, here's an example. We have, from my class, we create a new instance to which we assign to a variable called myInstance. MyInstance, when you display it, will show you that it was created from my class. That's the format, the display. But this is still a scalar. This is just a an object. And if you ask for the quadency, you will see that it's a class 9 object, just like the class, just like a namespace. Now, the display form may not be what you like. So if you want to change that, there's a new system function called display form, quad df, that will change the display form of your object. For example, I created one here called obj, and if you display it, it displays as being a my class instance with the brackets and everything. So that's the format. If you don't like that, and there's many reasons why you may not, for example, if you create several instances, you won't be able to tell which one is which. So you may, when you construct the object, decide that you give it a different name. For example, this one here, I decided to give it a name that's called OO class. And when I display it now, it says OO class. It's just for convenience. Here's a way to initialize, an example of how to initialize an instance. Here I have a class called animal. And when you create, all this class does is contain two public fields, one called sound, the other one called nlegs. And when you create an animal, you need to supply two things, the number of legs and the sounds it makes. And basically all it does is assign these two variables to what you've given up there. So it will assign the number of legs to nlegs and the sounds that you've given to the variable sounds. Okay, you can create several instances, and here's a function called build zoo. And what it does, it creates 4 animals. The first one is a tiger, giving the number of legs 4 and the sounds it makes. A second one called fish, 0 sounds, 0 legs, 0 sounds. Another one called snake, no legs, 1 sound. And finally a monkey, 2 legs and a series of sounds it makes. And at the end, it takes the 4 animals and puts them into a variable called animals. So this, if you go into workspace after that, once you finish running this function, you will see that in the objects, which is an old system command, you will find your fish, the monkey, the snake, the animal, and the animal class, which is the animal object, the animal namespace, which is a class. It appears in the list of objects. But if you look at the quadency of animals, it is not a class or a namespace or something. It is a variable. It holds 4 instances of 4 instances, but it is still a variable. And if you ask for the number of legs of each one of the animals, it will tell you that the first one has 4 legs, the second one 0, the third one 0, and the last one has 2 legs. So all the number of legs of each animal can be returned in one expression. Okay, message passing. As I said before, if you hear that in somebody say that, in your case, all it is calling a function, calling a method. Okay, this is the same slide we saw before. So we're going to see another example here with a bird and an instance of a bird. So the class bird, all it does is create a description of the animal, which is in this case plain bird. So if I do birdie is a new bird and I ask for this description, it tells me that it's a plain bird. In birdie there's a variable called DESC, and it contains plain bird once I've created the object. So when birdie was created, its constructor was called. Now, if the base class is a constructor, it has to be called. And the base class constructor is going to call when it encounters the implements constructor statement. When APL sees that, it says, okay, now is the time to call the base constructor if there is one. Now, if there's several classes, they're going to be called one after the other in the same fashion. So here's a little bit more complicated example. We have a parrot, and we had a class bird before. All it does is set the desk variable. And we have a class parrot, which is based on a bird. And what it does, here's the constructor for the parrot. When you create a parrot, it will first of all call the bird constructor, and then it will change the description to not a what is in the description, it's a parrot. So what happens now is that if you follow the construction, when you create it, the first thing it does, it calls the function hatch. The function hatch goes on to the statement implements constructor. When it gets there, it goes on to call the birds constructor method, which is egg0. That one will set the variable desc to plain bird and return to the following line after the implement constructor. And then it will set the variable not a plain bird, a parrot, and it will reset the desc field. So what you will end up with, is not a plain bird, a parrot, if you ask for the description of Coco. Okay, so of course from the parrot you could build, you could have a macaw class and so on and so on. This is just like the dog's example there. Well, let's have let's see an example with that too. This time the constructors will take arguments. Here's our animal class that we had before. It sets up still sets up the two fields there. We have the dog, which is an animal, which also sets the variable type. And we have a collie, which is a dog, which on top of that sets another variable called name. So when you create a new collie, and the argument is quote rex quote, it's a string, what you end up with at the end is the name, the number of legs, the sounds, and the type. So you have three classes, each one of them declaring fields, and you end up with the fields of all of them. So for example, I can ask for the pet's name and the type, and I end up with Rex, which was the name we gave it before, and the type, which was Canis familiaris. Let's go over that in a little bit more detail. So the first thing that happens here is that when you ask for a new collie, it will create an instance of a dog, and before that it will create an instance of an animal. This will create two fields. Going back it will create the type. Going back it will create the name. Does it make any sense? This is why you end up with 4 fields in the pet's instance. Let's go over that a little bit more slowly. Okay, we start from here. We give it the name. That goes into the argument of the constructor for the collie. This goes down there. First thing it does, it sets up a variable. I could have done that on a single line, but I was lacking space here. So I set up a variable and I pass it on as an argument to the constructor. And notice here you got colon base. What happens is that it says this is a constructor and it's based on dog, and here's the argument to the constructor of dog. So this is passed on to, the argument is passed on to the constructor of the dog, which is called make1, and make1 creates an argument for the animal class. He's going to give it 4 legs and the sounds, which is in this case of the dog, well, you see the 2 sounds there. So the 2 arguments, it needs 2, are passed on to the make method, which is the constructor of the animal class. And this creates the 2 fields. And then it goes back to, once it terminates, it goes back to the animal
the dog's constructor, which sets the type. This ends, returns to the constructor of the collie, which sets the name, and that's it. Well, this is a little bit far-fetched here, but I mean, it shows you how it works. Questions? It's all crystal clear? All right. Okay, encapsulation, as I said before, it conceals the exact details of how it works. And you have to use access to get at the access public to get at the member's definition. To expose a member, like I said, you must make it public. The default is private. For a property or a method, you have to use the access public statement. And for a field, since there is no definition of a field, it's just a single line, you use the public keyword after the field. You say field, public, and then the name of your field. That's the way you do it for a field. Okay, here's the same function we saw before. All those are fields, F0, F1, and so on and so on. And you can see those that are private and those that are instance. So the two keywords are private and public for the access, and for the if it's an instance, the keyword is instance. If it's in the class, the keyword is shared. So the last word in the field statement is the variable name. Encapsulation, shared versus instance. Every time you create an object, an instance from a class, all the members are deemed instance members. If you don't say that they're shared by using the keyword shared, then they're going to be instance members. Here's an example of shared versus instance. You want to keep the count of the number of instances you've created. So in this case here, each instance is going to have its own private ID and is going to have a public name. And the class itself will keep track of the number of instances it has created privately. So here, we're going to have count, which is kept in the class keep count. And each one of the instances will have its own, will have these names, these fields that it will keep track of. And my ID is private, count is shared, and my name is public. So in this case here, what you do is that IN1 is a new instance of the keep count class, and when it's called, what it does, it increments the count in the class, then keeps a copy of it of a my ID, and then it sets its own name publicly to XYZ, followed by the number that the number of times the class has been called. So it will say I am this. So the first time it says I am XYZ1. It was the first one in the series. The second one that is created goes over the same thing again, but this time the count is increased to 2 and says my name is XYZ2 and then displays it. So once you create it, the constructor displays I am XYZ2. Same thing with IN3, I am XYZ3. Once you finish doing these three things, if you look at the keep count, the class's count value, it is 3. And if you look at the variables in keep count, there's only one, there's count. The class only has one field that is visible. It's the shared public field, which is shared, and it's count. And that one you can see here. It's in the list of variables, list of fields. And if you look in IN2, the list of fields, well, there's count because it is shared. It can see it, and it's got its own my name, which is the public instance here. The other one is private, so we can't see it.
So in2 contains count, which is public, and my name, which is public, so you can see it. And if you ask for the count of in1, it is the same as the class. They're both the same. They should be. They're shared. And if you ask for in2 count, it will also be 3. Polyform Ism. Okay, APL cannot have different definitions of a single name, but you may have several constructors. They can have several definitions. APL is typeless, so there's no way to tell which function to call by looking at the arguments, but it can tell by looking at the number of arguments from none to any number you want. So here's a class that has 4 constructors. The first one is a general constructor. If none of the others fall into that category, it's going to be called. The first one is in the case there's no arguments, so this is the constructor that will be called. This is the case where you have exactly one, not a scalar, a one-element vector. This is the function that will be called. This is the case where you have exactly 5 arguments. This is the function that will be called. If the argument doesn't fall in any of those categories, this one on top there will be called. If this one wasn't there, and you didn't supply either 0, 1, or 5, APL would look and say, sorry, I don't have a constructor for this, and issue a length error. You would complain. The order is unimportant here. The important thing is that if you don't have a general case. One of the things you have to notice too is that if you only have the general case and you don't supply an argument, this won't match either. APL will say, well, I have a constructor for any number of arguments, but I don't have one for 0. So you would get a length error again. Same thing if you have a nil and you supply an argument. It would say, well, I only have a constructor in case you don't give me any arguments. So the number of arguments must match one of the functions there, one of the constructors. Okay, so we've seen that Dyalog follows the C# rules closely. We've seen that paren is to edit classes using the circle. That classes are much like namespaces, that their members, variables and functions, can all be accessed using the public access keyword. That quad new makes an instance, and the classes can be based on another one. And they all use constructors to initialize them.